imagine if you were an alien who, was visiting the Earth for the first time from some other galaxy. Imagine only visiting the United States and never visiting any other part of the Earth's surface. That's essentially what we've done with the Apollo missions, really been able to do wonderful and groundbreaking science with the samples, collected during the Apollo missions. But again, we visited only a very small part of the lunar surface.
The way that I think about it is it's the equivalent of, landing on Earth and getting rocks from Kansas. It would give us insight into one particular location on the Earth, but not at all the diversity of what we see on the Earth, what we know is present on the Earth. So the ability to go to a different site, a different location, get different samples will just enrich what we have already learned from our Apollo samples.
There's a lot left to be learned about the moon, and it starts with the South Pole.
Artemis astronauts will fulfill a different mission in a unique environment. While the Apollo astronauts who visited the moon's surface between 1969 and 1972 landed near the equator, Artemis astronauts will venture to the moon's South Pole region, frigid, rugged, and with unique light and darkness conditions that make it an ideal location for exploration. The South Pole region is also home to the rim of the moon's largest, oldest, and deepest crater, called South Pole Aitken. It takes up almost a quarter of the moon, and is so deep, it exposes portions of the moon's interior.
Yeah, the South Pole it's fascinating. There are some very unique types of rocks that are at the South Pole that will allow us to understand the entire history, not just of the moon, but potentially of the solar system.
Very early on in lunar history, we think that there was this increased period or very intense period of huge material hitting the surface of the moon, creating these really large craters or like giant holes, which we actually call basins. So getting a sample of impact melt from this basin would kind of help us bracket that early period of time.
The moon's South Pole region has resources that are vital for long-term exploration. Because the moon is barely tilted relative to the sun hovers over the horizon at the South Pole. Imagine a flashlight turned on, laying on a table. That's how the sun illuminates the South Pole. Light at the South Pole strikes at such a low angle, it brushes only areas of higher elevation, such as crater rims. These locations have sunlight for extended periods of time to harness for power. At the same time, the bottoms of some deep craters are shrouded in constant darkness. Scientists have measured the coldest temperatures in the solar system inside these craters, which have become known as perfect environments for preserving water for eons.
Over time, there's individual molecules of water and carbon dioxide and other gases that actually bounce around the surface of the moon. And when they get to one of these cold spots, they actually get stuck. So we call those places cold traps. And if you do that for millions and even billions of years, you can actually build up a pretty significant deposit of water and other ices.
From an exploration perspective, if we can understand just how much water there is and where it is and how to get it out of the regolith of the moon, we can turn it into really important things like drinking water for astronauts and even rocket fuel to take them back home. So really understanding these resources and how to use them is one of the objectives of the Artemis program, and it's what makes the South Pole of the moon so exciting.
We know the moon in incredible detail, thanks in large part to NASA's Lunar Reconnaissance Orbiter, or LRO. LRO has been circling the moon since 2009. It's the longest-lived spacecraft there. Through tens of thousands of orbits and data from 7 instruments, LRO has mapped the moon's temperature, geology, radiation environment, and is providing insight on how the moon is changing over time. LRO is led by Dr. Noah Petro, a planetary geologist at NASA's Goddard Space Flight Center.
LRO is this incredible mission. It was launched in 2009 as the opportunity to go back to the moon, to create this three-dimensional, high-resolution, high-definition atlas of the moon. Where are there safe landing sites for human and robotic explorers? So what LRO is doing is really giving us the tools, the material, the data we need to make those missions successful.
For many years, LRO's elliptical orbit was closest to the moon during the spacecraft's pass over the South Pole. So scientists have more information about the South Pole region than any other region of the moon.
We know that we can do more and build upon the legacy of Apollo, but to do that we needed a higher resolution data set. We wanted to know where the hazards were. We wanted to know where the geologic features were that we want to go explore, and so LRO has created that database.
singing me